Start recording. Today we're going to do statistic 2, topic 2, linear combination of distribution. Okay, so in this topic, okay, we are going to talk about 6 rules. Okay, the summary is actually written here. Okay, the problem for this topic is for students, the difficulty is actually reading questions and applying the correct rule. So I hope that through this lesson, okay, you can actually understand how to apply this rule properly, okay, and when to use them and how to use them. As I say, the most important part is actually understand, okay, how to read the question. Okay, so I'm going to name them as rule 1, 2, 3, 4, 5, 6. Okay, so my writing. Okay, so 1, 2, 3, 4, 5, 6. Okay, so when we it will be easier for me to actually explain to you which rule they are actually applying when we go through the example. Okay, then the very first one. Okay, so first one says, okay, you go straight to the example. Okay, example 3.1. So this is considered a standard questions. Okay, a standard question. Okay, questions. You have your original distribution x, okay, which is here. Okay, this original x being coded into y equals to 2x plus 3, okay, which is 2x plus 3 here. Okay, so now the questions want us to find, okay, the summary of y, okay, which is e of the 2x plus 3 here and the variance of 2x plus 3 here. Okay, to do this we actually got two methods. Okay, so one is construct new table or apply formula. Okay, we actually can do it as construct the new table or applying the new formula, apply the formula, which is what we're going to have, what you're supposed to learn in this topic. Okay, to show you the illustration, okay, so of how are they being related, I'm going to show you the both methods. Okay, first I have a x, okay, distribution x with 2, 3, 5, 7 with px equals to x 0 0.4, 0 0.1, 0 0.3, 0 0.2. Okay, first I would like to calculate, okay, expected of x first. Okay, expected of x. Then right now I'm doing the apply formula method. Okay, method 2. Okay, so I calculate the expected of x first. That actually give me 2 times 0 0.4 plus 3 times 0 0.1 plus 5 times 0 0.3 plus 7 times 0 0.2. Okay, let's see what do we get. Okay, so we plug it inside calculator. 5, 7, 0, 0, 0. So I will have the value 4 here. Okay, then I calculate expected of x squared. That actually gives me 2 squared 0 0.4 plus 3 squared 0 0.1 plus 5 squared 0 0.3 and 7 squared 0 0.2. Okay, same thing, I plug inside calculator, I have a 19.8. Okay, then after that the question asking for variance. Okay, so okay, this is a variance of 2x plus 3, but I'm calculating variance for x at the moment, so I will use expected of x squared minus expected of x the whole thing squared. Okay, this is 19.8 minus 4 squared So I have a 3.8 as the answer. Okay. Then how do we actually apply the formula? Okay, according to the rule here, I see that I have the coding of 2x plus 3. So I'm going to use rule number 1 and rule number 2. Rule number 1 says expected of ax plus b give you a of expected x plus b. If you see variance of ax plus b, then you do a squared variance of x. The b is gone. Okay, not there. Therefore, over here, if I want to get expected of 2x plus 3, what I'm going to do is by applying the formula, I have 2 of ex plus 3, where I already got the value of ex itself, which is 4. 2 times 4 plus 3, 8 plus 3. So I have 11. Okay. And similarly, for variance of 2x plus 3, so I have 2 squared variance of x. I just apply equation formula number 2. Yeah, variance of ax plus b, I get a squared of variance x. So I will get 4 times of 3.8. 4 times of 3.8, so I have a 15.2. You will see that by applying method 2, it gives me this answer. Okay, so now I'm going to show you method 1, constructing the new table. Okay, constructing the new table. So constructing new table, that means I will have to construct my new y value. So the y value is changed into, so as you can see, the original x coded into y, where y is 2x plus 3. So that means each of these respective x value I change into y. So I change into y. 2 times 2 plus 3, so it's a 7. 3 times 2 plus 3, therefore I have a 9. Okay, 2 times 5 plus 3, so 10, this is 13. Okay, and 7 times 2 plus 3, 14 plus 3, 17. Okay, then over here, I will have a probability. This 7, the probability is come from the 2. The probability of 2 appear is 0.7, 0.4, therefore this will be remain as 0.4. This 9 is actually came from 3. That's 3, the probability is 0.1, therefore this is also 0.1. This 13 came from 5, which is probability of 0.3, so therefore this is 0.3. And 17 came from this 7, the probability is 0.2, so I write 0.2 here. Now I calculate the expected of y by using the similar way, okay, S1 method. So 7 times 0.4 plus 9 is 0.1, plus 13 0.3, plus 17 0.2. Okay, let's see what do we get. Press calculator. Equate 7, 9, 13, 17. Okay, so 0.4, 0.1, 0.3, 0.2. Okay, I get the value 11. Okay, what about expected of y squared? So I have a 7 squared 0.4 plus 9 squared 0.1 plus 13 squared 0.3 plus 17 squared 0.2. Okay, I get a value 136.2. And my variance of y, okay, I use expected of y squared minus expected of y the whole thing squared. Okay, which give me 136.2 minus by 11 squared. That actually give me 15.2. From these two methods, you realize that they give us the same result. You will see this is 11. This is also 11. This is 15.2. This is also 15.2. this is how they are being related. Okay, this is how they are being related. Okay, so according to the design of the questions, it's not that all the time they actually give you the table. Okay, then you will be expected to know how to apply this formula, and even sometimes it can convert it into an algebra formula, maybe involved with simultaneous equation, maybe involved with the quadratic equation. Okay, depends on the difficulty of the question, but this is how they are being related. The method one, without using the formula, okay, by constructing the new table. And method 2, okay, retrieve the information from the X first, and then we apply the formula. Okay. Second example, as you can see, obviously there are no table given, okay, but they expect you to recognize what is the distribution. Okay, what is it? The random variable X is the number of tails obtained when 3 fair coins are tossed. So X is the number of tails of tails appear. Okay, so this is fair. Okay, so X is, by now you should recognize that is a binomial with 3 and 0.5. Okay, 3 and 0.5. Then from here, this is purely recognizing. It depends on how well you can remember your S1. Okay, then after that, since we recognize this is a binomial distribution, therefore expected of X will be NP, which is 3 times 0.5, will be 1.5, and the variance of X will be NPQ, okay, will be 3 times 0.5 and 0.5 again, so it will be 0.75. Okay, then 2i, so we apply the formula e of 2x plus 1. Okay, by now you need to remember how to apply the formula. For those who still cannot remember how does the formula look like, okay, please aware that expected of ax plus b equals to a expected of x plus b. Okay, variance of ax plus b equals to a square of variance x. This will be the first two formula. And from here, we apply the formula accordingly. So 2 of ex plus 1. So 2 times 1.5 plus 1. Okay, 3 plus 1, so this is a 4. And for variance of 2x plus 1, you will get 4, I should write it properly, 2 square variance of x. Where is the 1? The 1 is gone. As you can see, there is no plus b over there in the formula. So I have a 4 times of 0.75. Okay, so this 3 over 4, so this is the answer is 3 over here. Okay, so from this example, what do you observe? You'll be expected to remember the distribution that you should know in S1, okay, such as discrete uniform, binomial, geometry, or even normal. Okay. Okay, this is just a further example. Okay, as you can see, it's just a similar way. Okay, it's just that this time is in the form of minus. Okay, what happened to the minus? So this is a binomial distribution, therefore expected of x is 8 times 0.3. So press calculator, 8 times 0.3, you have a 2.4. And variance of x will be 8 times 0.3 times 0.7. Okay, then you have a value 1.68. So from this question A, expected of 4x minus 1. Okay, so you have a 4 expected of x minus 1. So 4 times 2.4 minus 1. As you can see, it's just a simple substitution. Okay, then you have a 8.6. And B, not expected, variance of 4x minus 1 will give you 4 square of variance of x. Okay, that gives you 16 of 1.68. So 16 times 1.68, that actually gives you 26.88. Okay, that is the example. Okay, now we're going into more formulas. Okay, that will be rule number 3 and rule number 4. Rule number 3 says if you have two different distribution, okay, and somehow they are adding together, okay, then they can actually add like this. Okay, so a multiple of b is still similarly like rule number 1. You just take it outside. If you have variance, okay, so regardless plus or minus, okay, this one will always be plus. How do we actually read it? We actually read as negative b squared. Okay, we read as negative b squared. So therefore, this is always a plus. It's a positive form. Okay, let's look at the example. How do we use the formula? Okay, from this example 3.4 from the textbook, okay, I have two different distribution, x 2, 3, 5, okay, with the probability of x 0.2, 0.3, 0.5, y is 0 and 1, with the probability of y is 0.6 and 0.4, okay. Then over here there is one keyword, independent. For your information in your statistic, okay, all the exercises, the question will be designed to be independent. Therefore, whatever that the formula that you learn above, they are all based on the condition that the x and y, they are independent of each other. But when you enter into university, you will be encounter more advanced formula. Maybe they will tell you that not independent. Okay, that will be another set of formulas. Right now, we ignore that at the moment because according to your current syllabus, they will be designed such that they will be independent. Okay, so A, draw the probability distribution table of the random variable S, where S equals to x plus y, and find the expected of S and the variance of X. So this one will be back to S1 technique. Okay, so the table method construction. Okay, let's see how do we do for this question. So first, okay, I have S, which is x plus y. So I have my x, which is give me 2, 3, 5, and my y give me 0 and 1. So I draw the table. Okay, I split it in between. The value is S, and this is the probability. Okay, the S says is the sum of the two numbers. Therefore, I will get 2, 3, 5, 2 and 1, 3, 4, 6. Okay, and for their respective probability, 2, 3, 5. So if this one 2 is 0.3, 0.2, this 0.3, and this is 0.5. Over here, this is a 0.6, and this is 0.4. Okay, then 0.2 and 0.6, we times them together. So I have a 0.12 over here. Okay, 0.6, 0.3, I have a 0.18 over here. Okay, 0.6 and 0.5, I have a 0.3 over here. 0.4 and 0.2, let me write down properly. 0.3. Okay, 0.4 and 0.2, 0.4 times 0.2, I have a 0.08. Okay, 0.4 times 0.3, so it's 0.12, and you have a 0.2. Okay, if let's say you would like to check whether do you get things right or not, so or whatever the value here, the probability here, we actually can sum them up together, make sure that it's equals to 1. So 0.12 plus 0.18 plus 0.3 plus 0.08 plus 0.12 plus 0.2. So it is equals to 1. So we are safe. Okay. After I apply the table technique, okay, so we're going to draw the distribution table. Okay, distribution table. So what I'm going to get is S equals to S. The value will have 2, 3, 4, 5, 6. And the probability of S equals to S. Okay, so this will be 0 0.12, okay, 0 0.26, okay, 0 0.12, 0 0.3, and 0 0.2. Okay, so in the end, they still want us to calculate ES and variance of S. So ES, okay, so I have a 2 times 0 0.12, 3, 0 0.26, okay, all the way to 6 and 0 0.1, 0 0.2, okay. Then your expected of S square, you have a 2 square 0 0.12 plus 3 square 0 0.26 dot 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 to 6 square L 0 0.2, and the end you have a variance of S, okay, equals to expected of S square minus expected of S the whole thing square. Okay, please take a moment to do this calculation. Okay, I believe now you can actually get the answer. So let's see what exactly is the answer. Okay, so I press inside calculator. Okay, I got my value. This one to be 4.2. This one to be 19.44. And this to be 1.8. That's the answer. Okay. Then I still need to calculate the distribution table for t. Okay, distribution table for t. So therefore, I'm going to do the similar way. Okay, but this time the t value is x minus by y. So I'm going to borrow this. Interesting. Okay, I'm going to change s into t. Okay, going to change s into t. Okay, so t, it says that t equals to x minus y according to the question. So, okay, 2 minus 0 will be remain 2, 3 minus 0, 3, 5 minus 0, 5. Okay, 2 minus 1, 1, 3 minus 1, 2, 5 minus 1, 4. Okay, now I will have a new table. So why the probability I didn't erase and change the number? Because this 0 0.212 is still from the same box. X equals to 2, y equals to 0. Therefore, the probability is not changing here. But of course, in the end, the final distribution table for the t will be different from the s. So we have a value 1, 2, 3, 4, 5. Okay, and the probability of t equals to t, okay, will be 0 0.08. Okay, then 0 0.24. This is 0 0.18. This is 0 0.2, and this is 0 0.3. Okay, so I would like you to do this calculation and tell me what is the value. Okay, after you do your calculation, you need to get 3.4 and the variance will be 1.8. If you are not sure about the calculation, please text me, okay, on how to do the calculation. Okay, now in the end, the whole section is about learning the formula, isn't it? We are doing so much to actually do the construction. Okay, I need to create this, I need to create a second table, I need to do the calculation, so many works to do. Therefore, the question arises here is there an easy way? Okay, which is we apply the formula. Okay, so applying formula. Okay, to apply a formula, we will first need to get the value of Ex, variance X, E of Y, and the variance of Y. Okay, this should be an easy calculation. Okay, so I will have the value 3.8 here and 1.56 here, and the variance of Y. Okay, this is 0.4 here. 0 and 1. And the variance value is 0.24. Okay, so how do we apply the formula? According to the formula, okay, let's see. Expected of S is expected of X plus Y. According to the formula, it will be expected of X plus expected of Y. That will give me 3.8 plus 0.4. That actually give me 4.2. As you can see, this and this actually consistent. And variance of S will be variance of X plus Y. That actually give you variance of X plus variance of Y, which is 1.56 plus 0.24. That actually give you 1.8, which is also consistent. Okay, sorry, we're actually out of space. I'm going to squeeze a little bit. Okay, and for the expected of t, which t is x minus y, that actually gives us a very expected of x minus by expected of y. That will give me 3.8 minus 0.4 give you 3.4, which is also consistent. Yeah. And variance of t equals to variance of x minus y, according to the rule, is variance of x plus variance of y. That actually gives you 1.56 plus 0.24 equals to 1.8, which is also consistent. Okay, so this is how the rule being related. As I say, this depends on the design of the question. Usually, the question not going to give you this, and the question will be expect you to know how to apply the formula immediately. Okay, we go for the next example. Example 3.5. The random variable x is binomial 12 0.2, and the random variable y is another binomial with 2 0.8. And I have a random variable w equals to x minus y. Work out the expected and the variance of w. So this one is just purely applying the formula straight away. So expected of x equals to 12 times 0.2. So press calculator, 12 times 0.2. Okay, so you have a 2.4. And the variance of x will give you 12 times 0.2 times 0.8. Okay, that gives you 1.92. And expected of y, which is another binomial, we apply the formula 2 times 0.8. Okay, 2 times 0.8, I have a 1.6, and the variance of y give you 2 times 0.8 times 0.2. Okay, that gives you 0.32. So from here, to calculate expected of w, which is expected of x minus y here, according to the rule, will be expected of x minus expected of y. That actually gives you, okay, expected of x minus expected of y. So 2.4 minus 1.6, 2.4 minus 1.6 gives you 0.8. And variance of w, okay, give you variance of w, which is x minus y. According to formula, which when we separate them, it becomes plus. Okay, therefore I will have 1.92 plus 0.32, 1.92 plus 0.32, that gives you 2.24. Unfortunately, this is a question that you cannot check answer. It's totally rely on how confident are you with the formula. Okay, if you do writing the plus minus sign wrongly, okay, if you are not careful, you write it wrongly, you can't really do checking. There's no way for you to do checking. So once you get a 0.8 or 2.24 during exam, you will have to be really confident that that's the correct answer in order for you to continue with the next part. Usually you will have a part 1, part 2, part 3. Okay, if let's say this is usually appear as a part 1, if your part 1 is wrong, of course your part 2, part 3 will be affected. Okay, now when is 2x not equals to x plus x? Okay, so we're going to do a real world situation. Okay, then to see the differences between multiple and sum. Multiple and sum. Okay, let's look at the example. Promotion A, 50 bucks for 3 cups of grande size Starbucks. Okay, you have 3 different cups. Therefore, this is representing the sum. Okay, promotion B, 50 bucks for the jumbo size equivalent to 3 cups of the grande size Starbucks. This is representing the multiple. Okay, multiple versus sum. As a customer, which promotion that you choose and why? Okay, you are at the customer point of view, not at the manager, not the store owner. Okay, you are actually at the customer, which promotion that you're going to go to. Okay, so we're over here in the context of this topic, we're going to investigate their mean and variance. Okay, so I have, first of all, I need to see, okay, we let, okay, so for 1 cup, okay, so 1 cup, okay, maybe expected of x, we call it mu, and the variance of x, we call it sigma squared. Okay, this is a setting that we set for at the moment. Okay, this is a setting. And from here, we're going to start calculating, investigating for the sum. Okay, versus the multiple. The sum here, let's s equals to x1 plus x2 plus x3, because you have 3 different cups. Okay, you have 3 different cups. So expected of s will be expected of x1 plus x2 plus x3. Okay, according to the rule, is expected of x1 plus expected of x2 plus expected of x3. Expected of x1, according to the setting, we set it already equals to mu. So this one equals to mu plus mu plus mu. The result is 3 mu. Okay, so we leave it as is. Okay, then next, I also want to calculate variance. Okay, variance of S. Okay, so variance of S is the same as variance of x1 plus x2 plus x3. According to the rule, is variance of x1 plus variance of x2 plus variance of x3. Okay, so over here, I will have a sigma square plus a sigma square plus a sigma square that actually give me 3 sigma square. Okay, that's the result. Okay, so the sum part is done. Let's look at the multiple part. Multiple. Okay, the multiple says, okay, m equals to 3x. It's a jumbo size. Okay, I could use J. Okay, jumbo size. Okay, J here. So I would like to calculate expected of J, which is expected of 3x. According to the rule, the 3 can actually take it out. Therefore, I have 3 of mu here. Okay, this is the result that we get. Okay, we leave it as this as it is first. Next, I would like to calculate variance of J. Okay, the variance of J. So variance of J, I will have a variance of 3x. According to the rule, it will be 3 square of the variance x. That gives you 9 times of the sigma square. Okay, 9 times sigma square. This is the result that we got. Okay, now we're going to investigate the number. For the sum, okay, the mean, okay, and the variance give me 3 mu. For the jumbo size, it also give me 3 mu. For the variance, this one give me 3 sigma square, and this one give me 9 sigma square. You are a customer. Okay, you are a customer. You know that averagely, you're going to get the amount of 3 mu. Okay, you're going to get the amount of 3 mu. But for the variance wise, variance which is the measure of dispersion, measure of spreadness, this one actually smaller than 9 sigma square. Okay, as the customer, we want something to be more consistent. Okay, when you actually receive the product, it's more consistent. Therefore, we will choose to go for the smaller variance. So logical thinking, we will actually go into promotion A for this offer. Okay, of course, we are not involving any sentimental value and so on. Okay, any other factor. It's just purely investigating based on the context of this topic. Okay, so this is the difference between sum and multiple. Okay, next example. What if we have a normal distribution? Okay, what here? Normal distribution. The mass in kilograms of small bag of rice and a large bag of rice are denoted as x and y respectively, where x is normally distributed like this, the y is denoted as the normal distributed like this. Find the probability that the mass of a random chosen large bag is greater than 3 times, so this one is multiple, than the mass of a random chosen small bag. So according to the sentence here, okay, the sentence here, so we need to translate the sentence into mathematics. So we have a probability of the chosen large bag is greater than 3 times of the small bag. Okay, small bag, sorry. the last bag is y. The last bag is y, and the small bag is x. Okay, so of course for the first timer, when they actually see this, they actually have no idea what exactly is, how to actually do the calculation, the probability calculation that involving two variable like this. Okay, so the first thing first, we actually move everything to one side. Okay, after that we need to write the distribution for y minus 3x. Okay, so therefore I will write expected of y minus 3x. Okay, maybe to help you understand better, I will change it into w. Let w equals to x minus 3y. Y minus 3x. So I have expected of w, that actually give me expected of y minus 3 times expected of x. That give me the value of 6.6 minus 3 times of 2.1. So 6.6 minus 3 times of 2.1. Okay, I have the value 0.3. And variance of w tell me that it will be variance of y plus 3 square of variance of x. Okay, y plus 3 times 3 square of variance of x. So I have a 0.4 square plus 9 times of 0.2 square. Okay, let's see what we got. 9, 0.2 square. So I have a 0.52. Okay, so from this information, I know that W is a normal distributed with 0.3 and 0.52 for variance. Then I can easily do my normal distribution calculation, which is Z greater than 0 minus 0.3 over square root of 0.52. Okay, press calculator. Press calculator. Okay. So you have a negative 0.416, and you need to read from your MF19. You will have a 0.661 as your answer. Okay, so this is how your exam question is going to look like. So there, in order to answer this question, okay, you need to apply linear combination formulas. Okay, now we're going to enter into example 3.7. Okay, it's still a continue with the normal distribution calculation. Okay, let's see. The lifetime in months of the Conti battery and the Thrift battery has independent distribution. The Conti battery is normal with 25 months and 1.1 square variance, and the Thrift battery, okay, is 7 months and 2.3 square variance. Okay, so what is the expected total lifetime of the variance of 4 randomly chosen Thrift battery? Okay, so let's see what is A1 is talking about. So A1 here, okay, so we are talking about sum. So 4 randomly chosen, this is representing sum. So for the sum calculation for expected of the sum, so it will be T1 plus T2 plus T3 plus T4. Okay, then T1 plus T2 plus T3 plus T4. So over here, okay, I have Thrift battery 7, so I have 7 plus 7 plus 7 plus 7. So I have a total of 28. Okay, what about variance? So variance for the sum. Okay, and I have variance of T1 plus T2 plus T3 plus T4. So the variance of the thrift battery is 2.3 square. So put 2.3 square plus 2.3 square plus 2.3 square plus 2.3 square. So I press inside calculator. So 4 times 2.3 square. So I have the value of 21.16. Okay. So over here, there is a sum. In order to help students understand better about the rule, therefore over here, I wrote rule number 5 and rule number 6. Rule number 5 says, okay, if you have expected of sum of x, you can write as n times of expected of x. And if you have variance of sum of x, you can write as n times of variance of x. Please aware this is not n square. Okay, this is not n square. And as you can see from here, this 28 is actually 4 times of the 7, which is 4 times of expected of t. Okay, and this 21.16 is actually 4 times of 2.3 square, which is 4 times of variance of t. Okay, so this one, the 4 here, there's no square. There's no square. Okay, because it's in the form of sum, not multiple. Okay, so you need to know how to write in the form of the summation way, so that you actually can apply the formula immediately. What if you have a 100 item? Okay, you can't really write T1 and T2, T3, T4 until T100, isn't it? So therefore, you need to know when to actually write it in the summation form. Okay, so next, AII. Let's see how do we actually, what AII is talking about. Find the probability of the total lifetime of 4 randomly chosen thrift battery is longer than 30 months. So I change it into mathematics first. So I have the sum is greater than 30. Okay, sum is greater than 30. So sum here. So this is a normal distribution. So Z greater than 30 minus 28 over square root of 21.16. So I press inside calculator. Okay, I have a P of Z greater than 0.4347 and applying the refer to MF19. Okay, so you have a 0.332. Okay, that's your answer. Okay, then B. Okay, what is the probability that the lifetime of a random chosen quantity battery is at least 4 times of a thrift battery? So question B here is actually totally different. So let's see how to actually deal with these questions. So for question B, probability of a random chosen quantity, okay, is at least 4 times of a thrift battery. Okay, this is similar to the rice questions earlier, the small rice and the large rice. Okay, it's just that this time you have a 4 times here. Okay, 4 times here. So we just do we rearrange them and write in the proper form first. So I have a C minus 4t greater than 0. Okay, then I need to find my expected of C minus 4t and the variance of C minus 4t. So expected of C minus 4t is equals to expected of C minus 4 times of expected of t. According to the information that we have, okay, expected of C is 25, 4 times of 7, so I have a negative 3. Then I have variance of C minus 4t. Give me variance of C plus 4 square variance of t apply the rule correctly. So as variance of C is 1.1 square, so 1.1 square, that has a 16. Variance of T is 2.3 square. Okay, add them up together. So 1.1 square plus 16 of 2.3 square. So you have a 85.85. Okay, then next we apply the normal distribution. Okay, I have Z greater than 0 minus 3 over square root of 85.85. Okay, of course, press calculator and refer to the normal distribution table. Okay, in F19. So P of Z greater than 0.3237 equals to 0.373 as your answer. Okay. Okay, we have more example. Let's go through them one by one. Okay. A melamine worktop, okay, is made from joining sheets of melamine and the chipboard. The distribution of thickness of the chipboard C in millimeter is normal distribution of 37 millimeter and 0.3 square. And the distribution of the thickness of the melamine is M, which is normal distributed with 1 mm and 0.01 square. Assuming the distribution are independent, find the mean and the variance of the thickness if the melamine sheet is added, just the top surface of the chipboard. So chipboard, melamine. So you can actually, maybe some of you actually never encounter what exactly is a melamine and chipboard. Okay, let me just draw this for you. Okay, you can imagine that this is a board. Okay, so the bottom part is the chipboard, the top part is the melamine. Okay, okay, actually can imagine this like this. Okay, then the question B is talking about the top and bottom of the surface of the chipboard. So it will be 3 layer. Okay, 3 layer will be look like this. Okay. So you can, this is the melamine board, this is the chipboard, and this is the melamine board like that. Okay, you can actually imagine it in that way. Then okay, so what will be the mean and variance of the total length, total thickness? Okay, let's call this A and this one B. So for question A, expected of A will be expected of melamine plus chipboard. Okay, so it will be expected of M plus expected of C. That actually give you, okay, around 1 plus 37. This give you 38. And variance of A will be variance of M plus C. That actually give you variance of M plus variance of C. That give you M 0.01 square plus 0.3 square. Okay, so give you 0.01 square plus 0.3 square. So 0.0901. Okay, this will be the answer. This will be the answer. For question B, it will be 3 layer. Okay, expected of B will be expected of melamine equals to expected of melamine plus C plus melamine again. So it will be 1 plus 37 plus 1, that should give you 39. And the variance of the B will give you variance of melamine plus chipboard plus melamine, give you 0.01 square plus 0.3 square plus 0.01 square. Okay, so it gives you 0.0902 as your answer. Okay, so some students will actually worry about the long lengthy questions. You don't really need to worry much about the wording. Okay, just make sure that you understand what the question is actually talking about. Therefore, the keyword of this working is adding. Okay, the keyword of this question is actually adding. Okay, now we deal with Poisson distribution. Okay, Poisson distribution example. We are just applying the same rule. Okay, then work example 3.10. Josh and Ruben keep in touch with their parents by text. The number of text messages sent by Josh and Ruben are independent. The number of text messages sent each week by Josh has a Poisson distribution of 3.2. So Josh has a Poisson of 3.2 per week. Okay. Okay, the numbers of text messages sent by Ruben each week has a Poisson distribution of 2.5 per week. Okay, write down the distribution of T is a random variable defined as the number of text messages sent each week by Josh and Ruben. It will be Josh and Ruben here. Therefore, over here, you have T is a Poisson of 3.2 plus by 2.5, 3.2 plus 2.5, so you have a 5.7 per week. Okay, so what we're actually talking about is if you have one Poisson, another Poisson, when you add them together, it will still be Poisson. Okay, add. Okay, it still be Poisson. Then after that, we just do the calculation. So for P of T greater than 5, okay, so it will be 1 minus P of T lesser equals to 5. That actually involves 0, 1, 2, 3, 4, 5. Okay, so E of negative 5.7, then 1 plus 5.7 power 1 plus 5.7 power 2 over 2 factorial all the way to 5.7 power 5 over 5 factorial. Okay, then you'll get your number. So you have a 0.505 at the end. Okay. Okay, now we have another example. Okay, x and y also Poisson, but I have a 2x minus y. Okay, 2x minus y. So expected of t equals to expected of 2x minus y. That actually gives you 2 expected of x minus expected of y. This is according to the rule. So 2 times 2.4 minus by 3.6. So 2 times 2.4 minus 3.6. I have a 1.2. And variance of t is variance of 2x minus y. You have a 4. Okay, I better write that properly. 2 square variance of x plus variance of y, okay, give you 4 times of 2.4 plus 3.6. If you remember correctly, the mean of a Poisson distribution is the lambda. The variance of a Poisson distribution is also lambda. Therefore, this is 2.4, this is 3.6. So, of course, we plug in the information. Okay, I have the value 13.2. Okay, so we managed to get 1.2 and 13.2. This part. Explain why random variable t does not follow a Poisson distribution. This is actually back to theory. Okay, remember that when we talk about Poisson distribution, one important characteristic for Poisson distribution is, okay, the expected value must be about the same as the variance. Okay, then if this happen, then we say that it's a Poisson distribution, or maybe it looks like a Poisson distribution. So over here, by observation, you see that 1.2 obviously not equals to 13.2. Therefore, your conclusion that T is not Poisson distribution. Okay, so please practice the questions. Okay, this is the last example, and I will hope to see you again for the next video. Okay, just make sure that you know how to apply the rule by reading the questions. Okay, thank you very much.